if you're inside a class, you don't need to qualify any inner class name with the names of the current class or its enclosing classes, and this can lead to some very subtle and unexpected results. And here's an example of that. We've got a group of classes here, and in this class E we've got this field F, which is of type D.B, which on the face of it looks like it will give a compiler error, but in fact it doesn't. And here's how it's interpreted. Well, for a start, class E hasn't got an inner class D. Okay? Because it hasn't got an inner class D, it means that that D must have been inherited from C. Okay? So what you got there really is C.D.B. Now, C.D does indeed exist. It exists there. And but C.D, that class there, has got no inner class B. Okay? Therefore, what you have to do is look at C.D's superclass, which is A. So what you should be looking for then is A.B. Of course, A.B actually exists, and so your initial D.B is really A.B. And sure enough, when you compile this thing, that's exactly what you get. When you look at class E, then you get this field, A$B. And it shows that D.B actually resolves to A$B. So that. And that's a bit of code for E, which is not terribly important. That's just a constructor. Okay, let's see if we can look at some three more examples. So I've put different choices of inner class here. So if we have this choice of inner class sitting inside of E, then what happens is D.B, of course, gives A.B again, but this time it's determined by E.D. So it's determined via this class here. Now if we have D extends C, this gives an error because it comes across this D, and the first thing it's going to do is go for the inner class, and having matched up that, it's going to discover that B cannot be found in either in the this class here, and it can't be found in C either, so therefore it gives an error. In other words, it won't backtrack and look through the superclass C. Once you've supplied it with a D in here, that's it. It will go down this route. Right, if we look at this, if we put any arbitrary class in there, like that F, of course it's going to give the same as the top example. That's this example up here. In other words, it was C, D's not in here, so it'll go via that C and so on through there to A, and then finally to AB. Okay. There's been a minor difference between various versions of the compiler, and in the earlier version, if you had a field, say called X, which was inherited by some class, and also the same named field, and another field named X was in an enclosing class, then the compiler would complain that X was ambiguous. But that's not the case now, and there's some definite rules to work out which X you're referring to. So what you do is this: if you're in some class like this one here, and it refers to an X, then pretty obviously, if you've got an X in that class, then that's the one you choose. Otherwise, what you do is you search the inheritance hierarchy of that class until you find an X. So you look at, in this case, you look at G, and if that one wasn't there, you'd choose that one there, so it would print out 2. And if that one wasn't there, it would print out 3. Okay? Now, and only if you run out of classes in the inheritance hierarchy, then you go to the immediate enclosing class, which is this one here. And so in that case, it would print out 4. And if that wasn't there, it would search through E. And E in this case has got this private static field called X there. Now, we haven't got access to that from this class here because obviously it's not a nested class and it's not nested inside of H, so that is private, so that's effectively going to prevent you from seeing the X in C. Because if you remember, a field hides all accessible fields with the same name in all superclasses, and it's only the name that matters. In fact, the type, whether it's static or not, doesn't make any difference. It hides it. That's quite unlike methods, of course. So, wouldn't find anything there. So the next thing that would print out would be 7. And if that wasn't there, then of course it's going to go for B, and it would print out 8. And if the 8 was not there, it wouldn't print out 9 because 9 is private and you haven't got any access from here for that private field. So that's what we'll print. And if you remember, unlike methods, of course, there's no requirement that the access level of the hiding field be wider than the hidden field, and so on. There's nothing like that, so it's all pretty crude and straightforward with fields.